Okay, we are starting a brand new unit of sequences. This week is arithmetic, next week is geometric. Okay, two different kinds, two different things going on. In your warm-up, you were trying to find patterns, and that's what sequences are. Sequences are patterns. Okay, so 1, 3, 5, 7, what happened each time? It went up by 2, or you added 2 each time, right? So what were the next 3 pieces in my sequence? 9, 11, and 13. Good. Number 2, what was the pattern? What did we do to go 13, 18, 23, 28? We added 5 each time. Good. So what are my next 3 numbers? There you go. Good. Number 3, what was the pattern? We subtracted 6. Good. We went down by 6 each time. Next 3 terms. No, you were right. You were right. And number 4, what happened each time? What about 7? Did we go up or down 7? We went up 7 each time. Good. So what are my next 3 numbers? 6, almost. 13 and 20. There you go. Good. So sequences are patterns. Okay? This is one of those things where it can be really easy, but it can also become really hard because you overthink it. Okay? So if you have questions, I know, right? If you have questions, if you get lost along the way, please stop and ask me, because once you get off that track, that's when it becomes really hard, because you can get really lost really quick. Okay? So don't overthink it, but if you get lost, tell me you got lost, we'll go back and we'll fix it. All right? So we're doing arithmetic sequences all this week, and next week we'll do the geometric kind. Okay? Our activity on Friday, we're going to need our Chromebooks, so make sure you have a Chromebook on Friday. Okay? Okay, we're going to go through some vocab. This is very Algebra 1 today, because you did do this in Algebra 1, but when you were in Algebra 1, that was the year of COVID, so you probably don't remember too much, or your class might not have even gotten to this. Okay, so we're starting real slow. Yes, Dalen. Right, yeah, we're starting real slow, and we'll just slowly get to the Algebra 2 level by Thursday. All right, so we are going to use the sequence. I think this was like number 3 in your warm-up, maybe, or number 2. 3, 8, 13, 18, 23, ... That ... means that this sequence is going to go on forever. Again, we're starting with basic vocab, starting slow. Probably stuff you think is obvious, but we got to talk about it. The 3, the 8, the 13, 18, and 23, those are the actual terms in the sequence. Okay, so there are 5 terms in this sequence. 3 is my first term. The number 8 is my second term. The number 13 is my third term. The number 18 is my fourth. And the number 23 is my fifth. So as we move along the sequence, we're adding terms to it. Any questions so far? Wonderful. All right, so this is an example of arithmetic, where each term is the sum of the previous term and a common difference. So you added or subtracted the same number every single time. If I added 2, then added 3, then added 4, that's not an arithmetic sequence. Okay? A common difference means you're adding or subtracting the exact same number every single time, forever. So that's our pattern this week. We're looking for adding and subtracting the same exact thing. So what do you think geometric is? Oh, look at you. You can see the future. Smart cookie, yes. So here's just some more vocab, how to write things out before we get really into the sequences. So if I have my first term, we write that as A with a little 1 underneath it. It's called A sub 1. That shows the first term, and in this sequence, my first term was 3. In function notation, I would write f of 1 to find the first term. That's just how we write it out, okay? So my term number is 2. We write that as A sub 2, which is the number 8. In a function, I would say f of 2, trying to find that second term, to get the formula to find the second term. There we go. Next row is my third term. So f of 3 finds the third term in our sequence. Now looking at the fourth term, what was the fourth term? It went 3, 8, 13. What was the fourth term? 18, yep. And then a formula is going to give us our fourth term. What was the fifth term? It was 23. So I would use f of 5 to find the fifth term. Okay, as we see a pattern going, we use n for any term. So a sub n represents any term. The term itself, we're not going to know what it is. So for f of n, we find the nth formula. So n is for any. Okay, yes. That's what happens when you add 5. Yep. Yep. Nothing. He just found another pattern. Don't worry about it. N means anything. So like if I could use a formula to find anything, I would use the a sub n. Like this formula works for any part of my sequence. That's when you would use n. You wouldn't specify which one. Okay. How could I find the ninth term of this sequence? So 3, 8, 13, 18, 23. How can I find the ninth term? Just keep on adding 5, right? Until I get to that ninth term. All right, so let's do that. So let's keep on adding. Let's try to get to our ninth term. So we started off at 3. To get to 8, we took 3, we added 5. To get to 13, I took my previous number 8 and added 5. We kept doing this pattern. 13 plus 5 gave me 18. Then we had to do 18 plus 5 to get my fifth term. We're trying to get to the ninth term. So what am I going to do for my sixth? There we go. Take our previous term and add 5, and that does equal 28. Good. How would you get the seventh term? Good. Our eighth term? Good. And finally our ninth term. Good. So we kept taking the previous one and adding 5 to it. Do it enough times, we get to our ninth term. Our ninth term is 43. Okay? So a general rule we could write for this is that to find any term, we could take the term before it and add our difference. So for this case, our difference was a plus 5. So to get my term I wanted, I took the one before it and added 5 to it. So the n minus 1 just shows the previous term. So to find the ninth term, I took the eighth term and added 5. Good? We see that pattern? Yes. Seeing the pattern is one thing, writing the pattern is something else. So let me know if we get stuck. This is called a recursive formula. I think recurse, reverse. You got to go backwards to add the difference to move forwards. So to find the term, we use the term before it and add our difference. So we have to know the term before. When do you think this would take a long time to use? Negative numbers? Log formulas? What if I wanted the 100th term and I only had the first 4? Would that take a while? Right? That would take a while. Just keep on adding 5 over and over and over again. So, no. So what would take a long time to use is if we were looking for large terms. If we were looking for large terms. So if we were trying to find something far away from what I have. Okay. We had the first 5 terms, so finding the 9th term wasn't that bad. We only had to add 5 4 more times, right? But if I'm trying to find the 100th term, that's a little further away, right? More work to do there. So I don't want to add 5 100 times. And guess what? We don't have to. We don't have to do that. There is an equation to use. It's a form of the first one. So to move forward, we add our difference, right? To get from my first to second term, I took my first term and I added my difference to it one time. Right? Adding that difference again is the same thing as taking the first term, which was 3, right? And adding my common difference twice. Because 8 plus 5 is the same thing as saying 3 plus 5 plus 5. I'm adding my difference twice. So each time I move forward, I'm adding another difference to it. So from term 3 to 4, take your first term and add your difference 3 times. Okay? So from the 8th to the 9th term, we take our first term, and we're going to add our difference how many times? We're going to take my first term and add our difference 8 times. To go from 7 to 8, we took our first term and added our difference 7 times. Correct. Yes. As long as we know our first term and our difference. So if we know where we're starting and we know how we're moving, we can find anything. Okay, so let's write an equation that kind of represents to finding any term in this sequence. So to find anything, what do we need? What always came first? Our first term. Good. And then what did we do after that each time? We added our 5, which was our difference, right? And we multiplied it by what? Not in. How do I represent the previous? N minus 1. So see how I'm finding my third term, so I multiplied by 2. That's n minus 1. I'm finding my 8th term, so I multiplied by 7, which is n minus 1. 8 minus 1. So I could find the 100th term here if I wanted to. Okay, this guy is called the explicit formula. So if you want a very specific term that's further away from everything else, you use the explicit formula. So one formula is not better than the other. Okay, recursive is really good to find something that's nearby. If I have the first 5 terms and I'm looking for term 9, I can do that. I can use recursive, right? Explicit's good if you're going far away. So if I have my first 5 terms and I want term 25, I would probably use the explicit for that one. Okay? So they're both good. It just depends on what you're trying to do with them. Are we staying close or are we going far off? Good. Okay.
I'm going to try the new line.
Okay.
Of course, I have been forever, so.
Well, you just let me know. Here we go. So here, we're going to look at both of them in the same problem. So number 1, we have 10, 4, -2, and -8. Okay? write a recursive formula, write an explicit formula, and then we're going to find the 42nd term. So we'll determine which formula to use to help us in part C. Okay? So remember recurse, reverse. So yeah, let's remember what that is. So to find a term, we needed the term before, and then we could add the difference. This is what we did. Okay? So what is my difference? That's what I need to know. Just 6? Good. We are subtracting 6 each time. And it has to be the same thing each time, otherwise it's not going to be an arithmetic sequence. So my difference is -6. So a sub n equals, take the previous problem. There we go. And then we're going to subtract 6 from it. So all we did was replace our d. All right, explicit formula. So if we're going far off, we can find any term as long as we have the first term, and then we can add to that the difference times n minus 1. So for this one, what was my first term? My first term was 10. Good. So start off with 10. What was our common difference? The -6 times n minus 1. So here's our recursive and our explicit formulas. That is the number 10. Think about what makes sense. We're trying to find a sub 1, which is the first term, so it makes sense that it's a 10. Nope, you're fine. All right, part C wants us to find the 42nd term. So am I going to use the recursive or the explicit formula? I would do the explicit, yes, because otherwise you're going to have to be subtracting 6 a whole lot of times with the recursive one. So yes, I would use the explicit. So we're finding our 42nd term. To do that, we take our first minus our difference times n minus 1. So n is 42. That is the term we're looking for. All right, let's do some math. 42 minus 1 is 41. -6 times 41, I think it's -246, but can someone check me? Yes? Okay, thank you. And then 10 minus that gives me -236. Good. So our 42nd term is -236. So this is my answer. Right, that's my answer. And then everything down here, this is all my work. So show me which equation you're using. Show me that you know how to plug it in, and then give me your answer. That's what I need from you. All right, you try the next one. We have 7, 17, 27, and 37. So I want you to find the next 3 terms. Write the recursive formula, write the explicit formula, and then pick one of those to find the 33rd term. Laura, you can help start me off about that. What is the next 3 terms?
47, 57, and 67.
Yes, there you go. 47, 57, 67. Beautiful. So we added the same thing each time. So what was our common difference? We added 10 each time. Beautiful. Okay. Who wants to give me the recursive formula? Ooh, we're gonna volunteer somebody. I think Trinity wants to tell me. n minus 1 plus 10. Beautiful. So whatever you want, you gotta go to the one before it and add 10 to it. Recurse, reverse. Go backwards and then add 1. All right, explicit. Who has that one for me? Look how Colin looks down real fast. He's like, don't pick me. Don't pick me. All right, Laura. C.
AN equals 7 plus 10, and then N minus 1.
Yeah, there you go. Good. I spared you, huh? Very good. So for this certain one, our first term is 7. Add in my difference of 10 times n minus 1. All right, Dalen. You said you wanted to do it. Tell me how to find... Well, first off, what equation did you use to find the 33rd? Explicit? Okay. So, tell me what you wrote. Mm-hmm. Beautiful. Good. And what did you get? A sub 33 equals 327. Good. For those of you who hate showing me work, this is the bare minimum you can do for me. Okay? This is showing work. You're showing me the formula you want to use, what goes where, and then this is your answer. This is the bare minimum. You gotta show me at least that. You just show me what you're plugging in, essentially. Yep, just show me what you're plugging into the equation, and then you can get, because I know a lot of it's calculator stuff. So 10 times 32, which gave me 320. So that's all the work. That's how we got to 327. That's everything. So work and then answer. Okay, ready for these word problems? Yeah, you are. We can do it. We can do it. Nope. Because the entire back of your homework. We can't skip it. All right, here we go. Johanna is conditioning all summer to prepare for her high school's varsity soccer team tryouts. She is incorporating walking planks into her daily training plan. Every day she will complete 4 more walking planks than the day before. Johanna starts with 5 walking planks on the first day. Write an explicit formula, okay, that's important, explicit formula that can be used to find the number of walking planks she completes on any given day. Okay, so for the explicit formula, what are the 2 things I need to know?
What number you starting with?
Where I start with and how we're moving forward. Good. So how do I know what she's starting with?
She's starting with 5.
Good. Starts with 5. It even says that. Starts with 5 on the first day. So A sub 1 is going to be 5. All right. Now we need a common difference. Does it show me how, like what she's... Yep, she will complete 4 more than the day before. So she's going to move forward each day by adding 4. So plus 4 and minus 1. Good. So A sub 1 and then D. Those are the 2 pieces you need. What's up? Not yet. Part A just wants the formula. Part B wants you to now use that formula to find out how many walking planks she is doing on the 12th day. So you do that.
How do we know if you're doing 4 every day?
In the description, it says every day she will complete 4 more walking planks than the day before. So that shows you she's adding 4 each day. Yep. So you work on part B. How much is she going to do on day 12? All right. What did we get for part B? Colin? 49. Ryan, did you get 49? Yeah, you did. Awesome. Yes, our answer is 49. Beautiful. So when we plugged it in, so to find the 12th day, we took our first term, we added the difference, 12 minus 1 times, which is 11. So we get 5 plus 44, which gives me 49. So on the 12th day, she is doing 49 walking planks.
Do that thing where like they always tell you like if you don't know the answer, please.
Right. All right, last one. We have a weather station. It is giving weather updates every 18 minutes. Okay? The first update is at 2 o'clock. And we turn on the radio at 5:30. It wants to know how long are we going to have to wait until the next weather update. Okay? So let's do this one together. Let's think. Okay, so if we try to use one of our formulas, I don't know the previous one. I know where I'm starting, and I know my difference. Issue is I don't know where I am in the line, right? I don't know what term I'm doing. I don't know which update, how many updates have gone by. I don't know. Okay? So I can't really use this. This explicit formula is not really going to help me with this problem. We're going to have to do some logic here. Okay? So we started at 2 o'clock. It is now 5:30. So how much time has gone by?
3.5 hours.
Yes. From 2 o'clock to 5:30, it has been 3.5 hours. Updates happen every 18 minutes. So let's convert this to minutes. How many minutes is that? Yeah, do 3.5 times 60. You're like an hour off. It should be 210. Okay, it should be 210. Because 3 times 60 is 180. And then plus 30. Yeah, we should get 210. So it's been 210 minutes total. Okay? So, let's think. 210 minutes has passed. Every 18 minutes there has been a report. So how can I figure out how many reports has happened so far? I can divide by 18. Good. So take how many minutes we've had. Let's divide by 18. What does that give me? How many reports have happened?
About 11.
11.66 repeating, right? So far, we've had 11 reports. And yeah, we're waiting for the next one. We're 0.6 close to the next one. 0.6 of what? What's my window? What's my waiting window? The 18 minutes, right? So let's take 0.6 and times it by 18 and see how many minutes have gone by. So let's round that to 12. So we've had 11 total reports. It's been 12 minutes since the last full report. You with me? Okay. This is more like a logical kind of problem, but we're still using patterns here. So if 12 minutes have gone by since the last report, how many minutes do I have to wait for my next one? 6. Right. We must wait 6 more minutes. Yeah, if it had asked what time is the next report, you would say 5:36. Yeah. But this just wants to know how long are we going to have to wait. Today is very Algebra 1. The Algebra 2 part would be to ask the exact time. So you're thinking in the Algebra 2 sense.
Why time questions?
Because they're fun.
No, they're not.
Yes, they are. Okay, so the problem we just did is going to help you with number 6 on your homework. The problem before this will help you with number 7 on your homework. So there's a reason why we did those in our notes, because you're going to have to do them on your own in your assignment, okay? So for the rest of today, we got a good, 12 minutes. We're going to work on this worksheet. I can help you. I can do a couple of them with you, okay? But you are working on the remaining, on the worksheet. If you get it done, turn it in. If you don't get it done, you'll give it to me tomorrow, okay? Yay!